The Markov property is telling us something about the conditional information of our random variable, but we typically don't just look at the outcome of one random variable in this context. We look at the outcome of a sequence of random variables or a stochastic process. If that sounds confusing, you can just think of something like a stock price over time. That is effectively a stochastic process. The Markov property states that if we look at the conditional distribution probability and statistics given all of the historic observations, then that is going to be equivalent to the conditional distribution just given the current observation or state. That is a massively simplifying assumption in the context of a stock price process. That means to produce the correct conditional distribution, I just need the stock price today. All of the historic information, all of the historic stock prices are just baked into the stock price that I observe today. In other words, the distributions are equivalent. If I include all of that historic data, all of that historic price data, or I just consider the price today. Why is this important? Because that is a massively simplifying result. I don't need any of that historic data. If you are trying to make some sort of prediction algorithm, then you don't need any of that information if the Markov property is true. You just need the price today. And that's going to give you the conditional distribution. There's no other information that you can then glean in a forward-looking sense. So what does this actually look like? Well, instead of looking at the sum of two dice rolls, what we're going to do is look at the sum over a series of independent dice rolls. I'm going to roll a dice, record the value, roll another one, record the value, and add them up. And I'm going to do that 10 times. This is effectively a stochastic process, and I'm visualizing the outcome here. In this roll of 10 dice, I've come up with a value, a cumulative sum of 38. And on the right here, you're going to look at the unconditional distribution of possible terminal values for this sum. It could be anything along this distribution. And this blue bar highlights this one set of rolls that we happen to walk. This is a stochastic process. Now, why is this important and how is this relevant to everything that we've discussed so far? Well, this is the unconditional terminal distribution. The distribution of sums at step 10 or roll 10 could be one of any of these values. Okay, well, what if I condition on the first 5 rolls? Now I'm looking at the distribution at step 10 at roll 10, but I already observed 5 values. What you're observing here on the left is now I've already seen this path up to roll 5. That's going to completely change the distribution at step 10. That is the idea of a conditional distribution, just like we talked about at the start of this lesson. We said that the unconditional distribution is very rarely equivalent to the conditional one. We can see this is completely different, this conditional distribution, given these first 5 dice rolls. If I was to then roll the rest of the dice, I'll create a draw from this conditional distribution, as you see here, this pink bar, right? Now, I'm conditioning on already observing these 5 values. But do I need all 5 of these values? The conditional probability here of this distribution given, I've already rolled all 5 of them. The Markov property says I don't need anything beyond the current roll or the current state. I can just use this current state to come up with the conditional distribution. I don't need any of these previous values. Okay, well, if that's true, then I should get the same conditional distribution, and I do. That is exactly what you're observing here. If I condition on only having this value at roll 5 or having all of the values back to roll 1, I get the same conditional distribution. That is this idea of the Markov property. It's tremendously simplifying because I don't need to keep a memory of all of the rolls up to the current state. I just need the outcome of the current state, the current roll, to figure out what the conditional distribution is. That is exactly this idea of the Markov property. That is the information. If I condition on the entire path, that is equivalent to conditioning on the outcome of the current state. That is why it is effectively memoryless. All of that necessary information is encoded into this current value that dictates the conditional distribution of interest. That is precisely the Markov property. After studying quantitative finance at the undergraduate and graduate level, master's, PhD, I was not satisfied with the transition from academia to industry, which is exactly why I built quantguild.com to help you master your quantitative skills for roles as a trader, a market maker, or a quant in the financial services industry with an adaptive practice engine that scales with your skill level so you can progress to more and more difficult topics. Over 100 hours of lecture content taught by myself, everything from A to Z. We're talking about first principles to the postgraduate level, encoding, stats, math, data science, research. The list goes on. Quant Guild is the platform that I wish I had when I was coming up to be a quant, and that is exactly why I built it for you guys. So if you're looking for roles in the financial services industry as a trader, a market maker, or a quant, check out quantguild.com to master your quantitative skills.